I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist, we have taken many examples for beginners to learn integration. We'll begin with the substitution technique. How do we use substitution to integrate in a couple of examples to begin with? Now, every video which I'm making this week will have three questions in it. It'll give you concept and practice to work on similar examples, and gradually we'll take level 2 and level 3 questions based on integration. So I'm going to discuss more than 100 questions with you during this week. You can start following us and master integration. Well, those of you who want to learn directly from me, you can always send an email on globalmathinstitute at gmail.com. We had been serving you for last 15 years. Most of my students are right on the top of their class. Okay, so here we have three examples in which the simple substitution technique will be applied. Let's try to see where can we apply this technique of substitution. Well, differentiation. So wherever you are doing chain rule, function or function type of things, those are the places where the reverse in integration is kind of substitution. So what you're looking for is a combination. So if you are given an integral of a function, in that case, you have to break it down so that you have a function of a function and a part of it is the derivative of that function, right? So you can break it down as a function and du and then get the answer. So these three examples are just to illustrate you the method. I'm going to take their solution immediately after telling you what the concept is. Okay, great. So the very first example, we have a polynomial x squared plus 1 to the power of 5 times 6x dx. Do you see some correlation between derivative and the function? Yes. What is the derivative of x squared plus 1, right? So the derivative of x squared plus 1 will give us 2x, and so we could write this as 3 times du. You get the idea. 3 times 2, 6. And we could do it. Perfect. So you have to basically define what u is, right? So in this case, you will define u as x squared plus 1, and then you have du, which is 2x, and that should help you to answer this question. In the next question, we know it looks very, difficult. We have x cubed over square root of x to the power of 4 minus 1. But in this case, if I substitute u as x to the power of 4 minus 1, in that case, what is du? Well, the derivative will be 4x cubed dx, right? So du dx, correct? So that is how it is going to be. So x cubed dx will now be replaced by 1/4 of du, and we have a very simple function to work with where the power rule for integration will be applied, right? So that is the whole concept. The next one here, we have 12x squared, fourth root of 2x cubed plus 3. Okay, great. Now in this particular case, if I substitute u as 2x cubed plus 3 within the radical sign, du will be what? 6x dx, correct? So simple as that. So I hope you got the hint and now you can finish it off. So in just a minute, you understand the concept. That is the beauty of my videos, right? And then we take up their solutions one by one. Well, I hope you got the solution of this one. A quick reminder, you can also support our channel, which is there with 17,000 plus videos. Your channel, since we are only solving your questions and helping you out. Perfect. And in case you want to learn from me directly, feel free to send an email. We can work out a schedule and we can be part of your success story. Great. So, in the very first example, what we were given was to find the integral of x squared plus 1 to the power of 5, 6x. And so we decided why not put u equals to x squared plus 1. And clearly, the derivative will be 2x, right? So du will be 2x times dx, right? So that is how we are finding the derivative. Now clearly I could write this integral as x squared plus 1 is u. So I have this as u to the power of 5, and instead of 6x dx, we know 2x dx is what du is, right? So we could write this as 3 times, then we have 2x. 3 times 2x is 6x, correct? Du, right? So that is what we could. So let me just explain it once again. Correct. Now, let's begin with the very first solution. So what you notice here is that x squared plus 1, the derivative will be 2x, right? So we could substitute u as x squared plus 1, derivative du dx. So we write du and 2x dx, right? So we got 2x dx, which looks similar to 6x, right? So let's first break down this integral into a very friendly term, which is x squared plus 1 to the power of 5. Since we have 2x here, let me write 3 times 2x dx. Makes sense, right? So now you see, I could make this substitution 2x dx as du, and u is already x squared plus 1. Makes sense, right? So let's rewrite this as integral of u to the power of 5 times 3 du, right? Now 3 being a constant, I could bring it out of this integral sign, u to the power of 5 du, and apply the power rule, right? So u to the power of 6 over 6. And that clearly is the solution, half of u to the power of 6, and we'll substitute back what the u was. It was x squared plus 1, right, to the power of 6. So that becomes the solution, and this is indefinite integral. It represents a family of curve, and so do not forget to write the constant c, otherwise you are going to lose marks for it, okay? You know, derivative of a constant is 0, and so when we go back, we have to always put c until and unless some conditions are given to us. Perfect. So, with that, we have done the first one. And let me also remind you that we are going to solve all these questions in this particular playlist and many more, right? Now, let's look into the second question, which is we need to find the integral of x cubed over square root of x to the power of 4 minus 1. Just as we discussed, x to the power of 4 minus 1 can be replaced with u, right? In that case, the derivative du dx will be 4x cubed dx, right? Now here we are given x cubed, right? So let me rewrite this. So if I rewrite this, I could write this as 1/4 of 4 times x cubed, right? dx. Does it make sense, right? And in the denominator, we have this radical x to the power of 4 minus 1. Correct. And now we are going to do the substitution, bringing 1/4 outside, right? So 1/4 is a constant, right? So we have integral 4x cubed dx is du, right? So we have du over square root of u. Now, square root of u means basically it is 1/4 integral of u to the power of minus half, right? Du. Apply the power rule. So what do you get? 1/4 u to the power of minus half plus 1, which is half over minus half plus 1. And do not forget to write the constant, correct? Now we can replace and simplify, right? This half will become 2 over 1, correct? And u is x to the power of 4 minus 1 to the power of half, correct? Which is our answer, which is half of square root of x to the power of 4 minus 1. Makes sense? So that is how we are going to solve it. I think it is absolutely clear. And those of you who really want to support our channel, feel free to sponsor and send your donations on email and discuss the possibilities for long term support We will try to reach millions globally. High quality education is something which is very difficult these days. We are providing it absolutely free. Your support can help. So now let's begin with the solution of the last question at hand, which is integral of 12x squared and fourth root of 2x cubed plus 3. So in this case, we could substitute the term in the radical, which is equal to 2x cubed plus 3 as u. And so du will be 6x dx. Makes sense? So 6x squared, sorry, x squared dx, right? So you see that 12x squared. So I need to break it down. 12 as 2 times 6x squared, right? Dx I'm writing here. And then we have this radical thing, which is fourth root of 2x cubed plus 3. Right. And now let's do the substitution. 2 outside, 6x squared dx is du, right? So this term is replaced by du. So we have fourth root of 2x squared plus 3, which is u. Makes sense, right? Du. So that is the right way of writing. I here swapped it kind of. Okay, not a good way of doing it. Now, fourth root means u to the power of 1 over 4, right? So you'll do 1 over 4 plus 1, right? Divided by 1 over 4 plus 1. Makes sense. Now, 5 by 4 is 1 over 4 plus 1. So you get 2 times u to the power of 5 by 4 divided by 5 by 4, right? Which is, you can do 8 over 5 u to the power of 5 by 4. Now, we are going to replace u with 2x cubed plus 3. We have 8 by 5 and power is 5 by 4. That is the exponent. And that is how we are going to solve it. So you see, we have done all the three questions with ease and have understood the method of substitution. So in this case, a polynomial was substituted as u. The other part combined with dx was du. And therefore, we could easily apply the substitution technique and answer the question. I hope the concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Also, you can support our channel. Thanks for your time and all the best.